grad student at University of Wisconsin under Dmitry Nanopoulos. I think it's almost 25 years or so. He went on to do postdocs at least Oxford, Zurich, and Daisy. And also was a scientist at Rutherford Labs before taking his present position 14 years ago at the University of Bonn. And he's a particle theorist by nature, has done a lot in the areas of supersymmetry and Higgs boson physics, but today he's going to tell us about the Bonn Physikshow that he's been organizing and leading.
So thanks a lot. Thanks for having me, and also thanks for so many of you coming here. So this is it's supposed to be informal, so if you have any questions at any point, please don't hesitate to ask. And I was just in California. I'd never been to Davis before, and I think it's very nice here. And I wanted to visit John and Robin, or Robin and John. And
We know who it is.
and so Robin roped me into giving this talk, which I hope you enjoy. And so I've been at Bonn a professor since 2000, and in 2001, in the fall term, I gave a classical mechanics, the theory course, the grad course. And well, in Germany it's not quite the same this year, divided. So anyways, it was actually the second-year course for physics students. And just before Christmas, I decided to give it a go and asked the students if they felt like doing this show. And I was completely overwhelmed by the response. And so the first performance we done did in the fall of 2002, so which is now more than 11 years ago. And we've been doing this ever since. And when I started this, I first went to Michael Kortman, who is the head of our demonstration equipment collection, which is huge in Bonn. I'll show a picture in a few minutes. And so I'm a theorist, as you heard, and I know very little about technology. And Michael Kortman, on the other side, seems to know everything about how all these physics experiments work. And we work together very well, and without him, it would be absolutely impossible to do this physics show. Okay, so as I said here already, it's a show that's performed by the students. So that's one of the important features of the Bonn Physics Show, and it's done for kids. And of course we do it for ourselves, and so we do it for fun. And this is we developed quite a while ago, in 2008, a show on particle physics. And we went to Berlin, where Germany organized a national exposition for the launch of the LHC, or the initial planned launch of the LHC. And they had these very large, so this is a photo in the background of the Atlas detector. I don't know if you have CMS here, but get over it. And so here's our group of students. Within the show, we have the boxes for the individual particles, we have the shells, and so we had a professional photographer was there at the event, and so they took this picture, and I'm right there. And the balloon, and I can't remember who, somebody had the Higgs already.
It's worth the time, probably.
Background.
Get so much background noise.
Okay, so as I said, this, it's an outreach project, or as I learned now, we're supposed to say public engagement, which sounds to me like I'm getting married again. And there seems to be no really good word for communicating physics to the public, but that's what it is. And that's how most people see it, but then actually for me it's not. It's something else. It's an educational project. And as I said before, it's the students, whereby I mean the university physics students that are involved in the project. And this is a photo of where we have all of our demonstration equipment. It's actually an old photo. We completely remodeled the place. And it's a special opportunity for the Bonn University physics students to just go hang out. So it's like twice as big as this room, our collection area.
Anything left over from Helmholtz or Hertz?
So yes, we do actually have from Hertz a replica built back then of how he discovered the electromagnetic waves in Karlsruhe, not in Bonn. He came to Bonn afterwards, and they didn't treat him very well in Bonn. They gave him fairly damp lab rooms, and then died of a lung disease. That's a fairly young age. I think
killed it.
he hadn't reached the age of 40 yet, unfortunately. But we still have this original, a replica of the original. And unfortunately, if you actually perform this electromagnetic waves experiment with the Hertz equipment, it's not well suited for stage, because all you see is on this little thing, you see this little spark. You basically have to go up and look at it, and it's still hard to believe that it's coming from something across the room. So it's not very good for demonstration. Okay, and so also we just simply have lots of fun. And so here's an outline of the talk. So I just want to tell how I came about to get involved in this, and the beginnings of our show, and how our show works, and how we've gone beyond the original beginnings, and in particular the particle physics show. So I mentioned before that we had this particle physics show in 2007 around we developed it, but we've just developed a brand new one. Actually, I'm kind of doing this in parallel, because in 3 weeks we're going to England with our brand new particle physics show, which also involves a lot of the Higgs physics, and we're going to Oxford and London to perform this show with 15 students. So here's 3 publications. I can give a copy of this talk to Robin if you want to read it. So I grew up in Williamstown, Massachusetts, which is where Williams College is, and my dad is actually a physicist. He wasn't he wasn't employed by Williams College. He was employed by a company, a research lab in a neighboring town, and but for fun, he actually taught lab courses at Williams College, and because of that, I then had, as a young kid already, access to the demonstration experiment collection at Williams College. And I just got to, on weekends and stuff, my dad sometimes had to go prepare some lab stuff, and I got to just play around with the stuff, and I really enjoyed that. And it turns out our students love to do this as much now as I did then. And as John mentioned, I went to grad school in Wisconsin. I did my undergrad actually in Bonn, in Germany, just by coincidence. And in Wisconsin for a long time already, since 1970, there's been a chemistry for fun, chemistry is fun, public outreach activity by Professor Shakashiri. And in 1984, which is exactly when I came to Madison, Professor Clint Sprott, who's he's retired now, but he's an experimental plasma physicist in Wisconsin, he started something called Wonders of Physics. And this was a show that he performed for kids aged 10 or older, and so it was presented by him. As you can see, he showed up kind of as a mixture of a magician and a circus MC or something. And he's also written a book about a collection of the experiments he used, and there's a long, I think, Physics Today article that he's written about this as well. And so I went to grad school at the University of Wisconsin, starting in '84, so I was there from the beginning. I did not actually participate in this show. So I was somehow more involved in my research then, and my love life, and that was a joke. But I went to the shows, and they always stuck in my mind, and so it wasn't until then I got to Bonn. So I worked at the Rutherford lab as a scientist for 5 years before they dissolved the theory group there, and they kicked me out. And so then I came to Bonn in 2000, so that was my first university teaching position. And so as I said, since Wisconsin, the idea of the show had been milling in my head, and then the fall term or winter term, as we say in Germany, I was teaching the second year students, and just asked them if they wanted to do some kind of a show. I had no plan actually. And actually 35 students signed up right away. And we were going to do this in the fall, but we didn't manage to do the show then until in November, so it took us more than 10 months of preparation. In the end, there were 15 students left over, and in November 2002, we did our first show. And I'm occasionally just going to I came from Germany last week, and it's impossible to bring, you're not allowed to bring almost anything on an airplane nowadays, and including, of course, physics experiment stuff. And so I'll just have occasional photos of stuff that we did. So I don't know if you know this experiment. It's just a tub full of water. Here's a normal can of Coke. In Germany, actually, you can't get cans of Coke anymore. They're illegal by the Green Party. And Diet Coke in Germany is called Coke Light. And so you put the normal can of Coke in and it sinks to the bottom, and Coke Light, since it's Coke Light, floats. Okay? And actually, if you take Diet Coke, though, it also floats, so it's not in the name. And so the reason is that you use an artificial sweetener in Coke Light, and our taste sensors are much more sensitive to the molecule, and so you need a lot less of it than you need sugar to get the same sweetness sensation. So that's why this is lighter than that, and it turns out the difference is exactly enough to just get you to get it to flow. And actually, I had just a few cans on my desk because the Green Party got rid of the cans, but it turns out it works with bottles also. And 5 years later, I discovered this can still in the back of my desk somewhere, and actually it had corroded. And the Coke had just...
Bottles have a little bit of air at the top.
Well, the cans do too, I'm sure.
I mean, that's why the can floats.
But so, I mean, of course, as I said, the main difference is because the sweetener, but I think it's more of a coincidence that it's just enough to get it to flow. Okay, this was the absolute first crew that we had, so here's my compartment. And I checked actually of all of these, I think all of the students except one ended up getting a PhD. So in between. So one of them left after a master. Everyone else got a PhD. And two of them got their PhD with me. So the basic idea is that the students themselves present entertaining and educational experiments for kids aged 10 to 99. The target group of the physics show, for me as a professor, are the physics students, not the audience. And so that's an important difference of what people usually expect. And the idea is, since we do this what you would call with undergrad students, they can apply their physics knowledge very, very early. They can build new experiments themselves. We give them the money, the resources to build something. And they can then explain this physics to young kids, which in itself is a great challenge. The students develop and present the show themselves. So each year we do a new show. I'll come to that. And the students do this in their free time, and they do this just for fun. And as I said, without Michael Cortman and his technical support and machine shop, this would not be possible. So every year, as I said, we have a new group of students. It's always the second and third year students. And every year they do a completely new show. And they see this kind of as a challenge. A lot of our students are from the region, and so they've, as kids, some of them already seen the show, and they want to then do something different than the previous people. And something we found very quickly, we didn't do that in the first show. It started a little bit in the second show, and since the third show we've been doing it all the time, is that we develop a story. So the show involves telling a story. And that turns out, I didn't realize this in the beginning, it just kind of evolved. And it seems to be kind of a core of what we consider our success. So the last show, which we're actually going to repeat next week when I get back, is just called, it's based on Jules Verne's novel, 80 Days Around the World. And so we have a story where the two students they want to do a physics show, one of the experiments doesn't work, they're missing a piece of equipment, and then they basically travel around the world to 4 different countries. We're going to go to Egypt, but it's just when we started, it was when the troubles in Egypt were something, so we didn't think it would be good to do a funny show about Egypt. And so we did Saudi Arabia, which is not really that much better. And China, and Chile, and Iceland. And as I said, the students choose these themselves, so this has nothing to do with me. So this is what I mean by we choose a theme or a story for the upcoming show, and it's around the story that so with the 4 countries, we then split the students into 4 groups, and each group then plans the experiments, let's say, for Chile or for Iceland. Like Iceland was typically then low temperature experiments. And they often build completely new experiments. You can find lots of stuff, online, and but also just from books and from ideas that people developed. And we have enough money, though, to build these new experiments, and I'll show you some examples of that. So here, when the big tsunami, not the one from the Japanese earthquake would be in Fukushima, but the one in the Indian Ocean before that, we then built a tsunami pool, and here with the slope, and we made different kinds of waves here. The surface waves are the kind of displacement wave that you have with a tsunami, and you could see the huge difference in the effects. And anyway, this is just something that the students then built themselves. Here you see several experiments. This is during the show, but here we have this track of magnets with a floating superconductor, high-intensity superconductor. This is fairly expensive, but the students have also built themselves. This is an old experiment, which is actually what the photo is about. Because here this Teletubby just fell down and was shot by an arrow.
So the high TC superconductor is in the...
You can't see it right now. I think it's in a separate... There it is.
Oh, okay.
So it's inside here, and you have to surround it with something that you drench in the liquid nitrogen so that it'll last long, stay cold longer. And then we also have another version, I can't remember if I have a photo, where then it goes upside down and comes back.
Where did you get the money for, does the university pitch in, or?
So we
get
have
grant?
we have a fund specifically for a whole demonstration equipment setup, and which is fairly generous. And so we have about 200 new incoming physics students every year. And in addition, we of course do, as you probably also do, teaching for the chemists and biologists and so on. And there's enough money in there to do this. So I didn't have to get extra money. So here's the upside down version. So here it comes and it goes upside down here. And it loses a bit of energy, of course, here, and then we've set up a thing here where a push of air, just so that it can keep going around. And this is something that took a while to develop. The students had this idea, so here's 6 little bubbles made up of a foil, which is, you can make with a special glue, you can make it helium tight. And so we fill these with helium, and in the front balloon, you can barely see it, it has 3 propellers. So it has, if I'm the balloon, it has 2 on the side that are like this, and 1 in the front of the nose, which is horizontal. And the second one carries the batteries for the front so that it works, and then the other 4 just go off for the ride. And we've also attached a camera to this, which we connect to our projection, so you can fly over the audience, and then they can see themselves on the screen and stuff. And we have a Nobel laureate in Bonn, Wolfgang Paul, who developed the ion trapper as one of the people, and so that's how we call this whole thing. This was a show that we did in Cologne.
So the point of that one is just helium?
The main point of this one is that it's lots of fun.
Because you can have a camera going and stuff?
Yeah, so we don't do any explanations when we show this. It's just,
Okay, it's just fun.
so we try to involve it though in the story. So in the second to last physics show we had a James Bond theme, and so then this was like a drone that was
Okay.
observing the enemy. So as I said, the target group of a physics show are the physics students, and here's at the end of each show we all come onto the stage that were involved in that show, and you can see that sometimes it's quite a lot. So here's Michael Cortland with his daughter, and I'm way over here on the left. We have developed these, this is our logo, which is an H and a nu, and then turned it kind of into a short-haired cat. And every year we do a new t-shirt and so on. And this is our physics lecture home. And so as I said, I'd written that before, I didn't say it. We usually do 3 shows. We do the new show in September, always 3 new shows. always a Friday, Saturday, Sunday. The Friday morning show is for high school students or school students, and then Saturday and Sunday is for general public. And we don't charge, so the shows are for free, and we just have a reservation system. And that was not me, though, right? Somebody sent an email there. Turn off your sound check. So this talk is already a little bit older, so as I said, now we're already in the 11th year. And we do have about 20 or 25 students per year, so we've done well over 200 students, probably more like 300 now, that have gone through. As if you would, I consider this kind of a training also, and outreach activities or just speaking to the public. Do you have a question?
Yeah, do students repeat the show? Or, like, are they allowed to come back and do another show? Or
Yes, so I'll get to that. So, there's one show that is like for their school year, if you wish. And then after that, if they want to continue, we do lots of extra other things. So we, for example, this trip to England in 3 weeks, those are all former Physikshow students that stayed with the program, if you wish. They're experienced. And so for them, for example, we need like half the times when we do rehearsals and stuff. And so there's, I would say like a third of the students stay on and continue. So our lecture hall seats 550 people, and we fill that basically every time. And so for me personally, it's a wonderful interaction with the students. And I also, again, get to play with the demonstration equipment, which is a theorist usually would get involved in. We've received 2 prizes. And one is the Alumni Prize of Bonn University, which is actually a prize for student initiative, which is to emphasize that it's really the students that do the main activity. And because of our particle physics show, we got the European Physical Society Outreach Prize for high energy physics in 2009.
How much of your time does it take now? Not the playing time.
I must say I delegate a lot. And so, for example, so I'm going back next week Sunday, so 10 days from now, and the week after that, the whole week is rehearsals for the repeat of the 80 Days Around the World show. And so with a normal show, we'll have like 10 days of full-time rehearsal before the first show. And of those 10 days, I'll show up maybe 1.5. Because it's the older students, as you were, the older students also train the younger students. And so how much time does it take? I don't know. I would say 20%, 25% of the time. So I have a normal teaching load, and I still do research, and I have a family. So I should have said that the other order. So this is our lecture hall. It's fairly wide, and what's really convenient also is that it slopes up, which I guess you have in your typical university hall, but we also played already in places where the floor is flat and you have a higher stage, and it's much better if the audience can look down and they can see much better all the experiments that you do. So what happens in a show, I usually do a short intro to welcome the audience and so on. I usually show 1 or 2 experiments. And we have 2 people usually that moderate the show. We've changed this format actually a bit now. For example, the show that we're going to England with, we're going to do like a time travel. We're going to go back to Cambridge when Rutherford was there. And so then we have 2 people that are going to do all the time traveling, and then we go to Rutherford, to Cambridge, to Berkeley, and to Daisy, to CERN. And in each place where we go, there's going to be 2 people that present the experiments and explain the experiments at that time. And so we have like typically 10 people now on a show that have speaking parts. The show takes about 2 hours, including a 15 or 20-minute intermission. In the intermission, we usually have, in the foyer, we have, well, here's an experiment we also often use. In the intermission, we have stuff, they can come up front to look at stuff, but we have a foyer of the lecture hall, we have lots of hands-on stuff. So here's a chair they can sit on and do, or they can also hold a bicycle wheel. And we have several tables worth of hands-on stuff. So we typically split the show into 4, maybe 5 topics, and so that splits the group. So So my favorite one was actually episode 5, which was the 5th physics show, which we did as a computer game. And so the moderators had to go through various levels of solving physics puzzles and thereby advance in the computer game.
So is that how you say Sesame Street in German?
No, that's who didn't ask remains dumb.
So Sesame Street in German is Sesamstraße, and but the motto in Sesame Street in German is this: if you don't ask questions, you'll stay dumb or stupid. It sounds better in German. Sorry? So, one reason I guess for giving this talk is if there's anything in it that you might find interesting to do here, or particularly the students. So my impression was, as I said, I just offered this to the students without even thinking about it, and immediately a large group came. They were very interested in. You can easily, I think this whole thing, my impression is that we do it on a fairly large scale, but I think the scale is fairly easy. You can do this on a much, much smaller scale, and just start with like a 30 or 15-minute show on an open day. And as I said, though, what we've learned, there's also an organization in Europe called Europhysics Fund, which is basically a European organization of people doing physics shows. And we meet once a year in various European countries, and this coming April it's going to be in Denmark. And these are people from all over Europe. And seems to be a consensus now that this idea of packing whatever you're doing in a story seems to really go well with the audience, with the kids. And so there's a high school group actually even just outside of Bonn, and they've been active now also for almost 10 years. And they've also recently switched to the story mode, and they find also that works much, much better.
Question?
Yes?
Here in the U.S., there's this movement, there's this thing called the maker movement. I don't know if you know about that.
No.
I mean, it's sort of a resurgence of people doing tinkering, making things. They have these things called maker fairs that I just wondering if you know about this or if you had any connections with.
No, nothing. So, I mean, in contrast, this is something that people come to and watch. But as I said, a large part of the target group for me are the university students, not just the public that comes. And so if you wish, the university students, they are tinkering. They are building stuff themselves. So over the years, we have this fairly large pool now, over 50 students. We've done other activities. We've developed films on YouTube. We just sold a film actually to a Japanese television company. Unfortunately, I can't do the experiment here. I just did it at the Exploratorium yesterday. For €1,000, they bought this film. So that went into the kitty, which is, of course, very helpful. So I can just describe the experiment because in the Exploratorium, they weren't able to get it to work. And so I was very proud to be able to show that. So it's just an aquarium. And then we built this, come on in. So we built this boat out of a very light aluminum foil, and it's strengthened a bit with styrofoam. And then you fill the tank with sulfur hexafluoride. And the important point is you have to fill the tank. Sulfur hexafluoride is transparent, and it's heavier than air, and so you can't see it, but you have to fill the tank completely to the rim. Now you can't see it, so you don't know if you filled it to the rim. So you have to try to make sure. And then you can just take this boat, and you can just let go, and it falls down, and it floats on the sulfur hexafluoride. Now, if you don't tell the audience beforehand what's in the tank, this is completely amazing when you see this for the first time. So you see a boat which is floating on nothing. And then you can actually take a glass, we actually do that in the YouTube video, you take a glass and scoop nothing and you pour it into the boat. And you do that like 200 times and then the boat sinks.
So
And then if you
is
take
that-
a drink of it, it makes your voice. Really
Yes, exactly. So we finish off to show what's inside. Well, you can do two things to show what's inside. You can pour liquid nitrogen, and just the steam from the liquid nitrogen settles on top of the gas. And then you can actually see the interface. Or you can stick your head inside. You can do that afterwards also. Take a deep breath, and then you, of course, talk about the monster.
do you have this one on the YouTube video?
So this, it is on YouTube, yeah, the ship is on YouTube.
Okay.
Yeah. And so what happened actually was that somebody, this is 8 years ago, somebody stole it, copied it and put it as his video on YouTube. And he then got 3 or 4 million, and we have like close to 2 million or something now. And, but then at some point YouTube became stricter with people doing this, and so they chalked him away. So, which is good on the one side, but all his viewings are gone now too. And so beforehand I could at least show, oh look. Now we're careful also that when we do something on YouTube, we put University of Bonn, and we were pretty naive back then too.
So I'll try to send around the link.
Yeah, I can send it to you. It's like 20
Yeah.
seconds, for 25 seconds. Actually, I might even be able to show it at the end here, because I guess, does this room have Edu room too? Probably. Yeah. So your question before was, do people continue? So we do continue then with the experienced students and do external shows. And so Bonn University actually has 2 campuses which are separated by about a mile. And so the downtown, the central campus is in an old 17th century palace, which is where all the humanities in, and which is also where Heinrich Hertz died. And then about 100 years ago, they built a science section a bit further away, and that's where we are. And so already, the first thing we did was just to go to the main building. And so, which a mile away sounds like nothing, but it's already a huge effort to get everything into a van, make sure you don't break it when you drive, to unpack everything, to set everything up. And when you're in a strange room, just having all the everything, cables, you have to make sure you have every single cable that you need. And so that was just a good way to start, because at least then you can still drive back and go get somewhere. And Bad Godesberg is actually a suburb of Bonn where they have a division of the Deutsche Museum. Then we went to Göttingen University, Solingen, Köln, Wuppertal. We've done elementary schools on a small scale, kind of 10-week programs in elementary schools. And so it gave the students also opportunities to think of ideas of how they could in various ways interact with the public. And this has actually now become 3 times. And one of our first big highlight was when we went to Munich to the Deutsche Museum and performed in 2006. And I remember during our rehearsals, the guy who was responsible at the museum, he was sitting in the room most of the time because it's a very old room with busts of all the famous people. I might have a photo of this. And he was, I think, afraid that we were going to destroy this room. He was completely horrified of how chaotic our rehearsals went. But then he was so happy when it all went off. We now have a standing invitation. We can basically go there whenever we want. So this is the main university building that I mentioned before, which is a Baroque palace.
It's still laser.
So that was some physics event. So actually coming from the physics building, there's several physics buildings. One of them is 8 or 9 stories. And one of the atomic or laser physics guys, as a public event, had the laser beam going across town. And with some lectures associated with it. So that has nothing to do with us, but it was an outreach activity of the department. So I want to highlight 2 activities that we did, which is one, we did a show, we actually went to a high school, and then with the high school, I guess high school is one word, and we went to the high school, and in German you capitalize the noun, so I get confused occasionally. So in the high school we went, and so I knew one of the physics teachers there fairly well. We went to the school, we organized the students, the high school students, into groups, and university students then tutored them. They could choose which experiments they wanted to do. They came to the university to rehearse with them for a while. And then a week before the show in the school, we took all the stuff to the school and set it up in their main auditorium. We were able to get the auditorium in the high school for a week. And they had also a group that was responsible for lighting and sound and whatever for the theater performances. And they helped us. And so this was a professional in-house sound and lighting crew. And so then here are some of the high school students. The audience was then they did the show for their fellow students. And in Germany, secondary school goes from 5th grade to, back then, 13th grade. So it's not like high school of just 4 years here. And so here's so we use the tsunami beacon again. And so here are the black t-shirts, these are university students, but these are all the high school students. And then, as I mentioned before, the particle physics show, that was the initial photo. It was taken in front of this huge photo. So there's a subway station in Berlin, which is right in front of Angela Merkel's office. And she's, of course, also a physicist. And it's a brand new subway station, which was made specifically also to put on events. And there's a platform down here where the trains run, but at the time it was not functioning yet as a train station. And up here there's a surrounding gallery. And the German Physical Society organized a exhibit on the LHC with lots of active physicists as tour guides. And we then came in and put on our show there. So here, just to give you an idea of how to do a show on an advanced topic, this is our old show before the new one we're doing is focusing more on Higgs and LHC. So we split it into 4 topics. And so we did the atom size by forming a thin film out of liquid. Then we had a homemade Geiger Miller counter. Back then we were still allowed to actually have radioactivity live on stage, which is now illegal. And we had a mercury spectrum, including the UV parts, and we had the various radioactivity absorbers. And this is a very nice experiment. It's just 2 metal plates and a little very thin paper, little animals, and if you rub your plastic stick with a cat thing where you put the electric charge here, then these guys start dancing up and down. And if you play the right music with a very good sound system.
So they're transferring charge up and floating down? In other words,
It actually goes very fast, so you induce a charge up here, and they're partly charged, whatever. Anyway, as soon as they get pulled up, they drop their charge here, and pick up the opposite charge, actually.
Oh.
And then so they go down actually very fast.
Oh.
And so you typically play some kind of dance music to this. It works surprisingly well. This show in Berlin was also amazing because we had huge arguments with the organization that were responsible for the sound and lighting. And when I talked for several weeks beforehand about how the stage was going to be set up. When we got there, it was all different. So then they were supposed to have to change it again. They had to bring their sound guy back in. And they had these loudspeakers that were maybe like this big, but they had, I think, 4 sets of them. And he then put on some bar talk or some music like that. And it sounded absolutely horrible. And then he had his little laptop and he went to each loudspeaker and started fine-tuning it. And in the end, you thought you were not in a subway station, but you were in a concert hall. It was really spectacular. They had really, really spectacular cameras for it. So we project the smaller experiments onto a screen so that you can see them better. This is one of our favorite experiments. It's a metal tube, which we evacuate. And we have here a plastic box. And now in Germany you can buy cottage cheese, which is actually called pork. And, so it's a fixed target experiment. We put a wooden piece here. Now in German the word for bolt is boson, so it sounds very similar to boson. So we call it a wooden boson. And here's the target, and here's the beam dome. And you have to be very careful when you build something like this that you don't make it too long, because then it can become very dangerous. And in Germany there are laws about weapons, and it's like another foot longer than would be prohibited because of German weapon laws. You don't have any laws against weapons. We have laws for weapons.
That one's hard to conceal, though.
Anyway, so you do it, and you pull off the plastic thing at the end, and then the air shoots in, and the bullet more or less really destroys this, and you get a splatter of cork, and then you can actually go in and read it out.
So here you use bosons to destroy quarks.
That's right.
The other way around.
And Howie Haber from Santa Cruz, who I'm actually mainly visiting, he claims, I'm not sure if this, I haven't been able to find this anywhere else, James Joyce, when he wrote Finnegan's Wake, he lived for a long time in Zurich, which is more or less German speaking. And they speak Swiss German there, which is a bit different. But, so, in Finnegan's Wake it says 3 quarks for Master Mark. And Howie thinks what James Joyce heard was 3 quark for eine Mark. And so it's at least...
But in the novel, it occurs right after he has a seagull.
Shit out of him.
Anyway, tell how he meant.
Yeah. So this is what it looks like afterwards. We put food coloring in typically to make it look better. And then you can go in and taste it. You can say, oh, it tastes strange. Or, at the top, it tastes really good. Oh, this is the experiment. I guess I could do this right now because this is just shown in this photo. I brought this experiment because it's transportable easily. So this is an experiment we do with respect to the Higgs boson. And let me do this on this shirt here. So this is an aluminum tube. I have here, this is aluminum tube. Now you can say that. I'm trying to show, I don't know, what American coins has iron in them? The German coins still do, so I don't have any with me. Anyway, so this is a magnet. I think you'll believe in that. This is just a piece of brass. And you can see that the magnet does not affect because it's aluminum. And so then the idea is that this would be your photon, and this is your background Higgs field, and your photon does not interact with the Higgs field, and therefore flies straight through, which is, as you see, the speed of light. And now here's your magnet, which, you're all physicists, so you know this, but you let it, and then it just takes quite a while. And it does eventually come out. Okay, so,
Everybody thinks friction does.
yeah, so it is, it fits loosely, so it's not friction. It's, you generate eddy currents. And so if this were superconducting, this is effectively what happens with the ITC superconductor. This would stop and just float, and it would never drop out. And so it is friction in this that the eddy currents die, and therefore the thing keeps falling.
You need a clear plastic to it,
Sorry?
You need a clear plastic to it, so that...
Yeah, but then it won't work.
Yeah.
I don't know, but I mean, showing that it's not friction that way.
Yeah. You can do, I have that, we have a metal ring also, and that goes on down the outside, and that does the same. So that you can see.
I just meant to demonstrate that it wasn't friction.
There is conductive plastic. I don't know if it'd be conductive enough to get it. Yeah. Clear.
Okay, maybe just because I started, I'll take this opportunity to just show the few experiments that I was able to transport. So as I said, I come from Germany, and when I was in high school, which I graduated in '81, believe it or not, and in Germany in high school you go on trips 1 or 2 years before you graduate, and if you're French major you have to go to France. If you're a math and physics major you can choose wherever you want to go of the things that are on offer. And I went to Hungary, and for the first time I actually met somebody from East Germany there, and I'm still friends, very good friends with them. And since then, since '79 to '89, I went to what was then East Germany at least once a year. And it turns out in East Germany, while it was still East Germany, they had a different kind of wood. And here's an example. So this piece of wood is from East Germany, and you can see it easily turns to the left. Okay, and if you turn it to the right, it doesn't like that, and it goes back to the left. Okay, now here, not so nice, but a piece of West German wood, which is probably from Bavaria, which is our Texas. So it easily turns to the right, and if you turn it to the left, it stops and it goes to the right.
Social lessons in there.
Okay. So that just to how much a story helps if you present something. Here's something I think John has
Not
seen.
going to tell us how it works.
To involve communism?
So there's actually a German textbook on classical mechanics which has like a 10-page calculation explanation of this. And so you can actually do it. Obviously, this involves friction. It only works on a table with friction. So these look like they're symmetric, but they're not. There are two kinds of them, and they're actually, one kind is where they've been cut down in the middle, and there's a piece of weight inserted here and here, so point symmetric but not mirror symmetric. And then here, obviously, the other way around. And sometimes if you look, but these are symmetric, the bottom is not straight.
Yeah.
That's another way of doing it.
So you can either make the external surface asymmetric,
Asymmetric
or
or
the weighted
Yeah.
asymmetric. Okay.
Well, it's still point symmetric, but it's not mirror symmetric.
Right.
So here's an experiment on gravity. So I'm a particle physicist, and we all know about left-handed neutrinos. And this is an experiment on chiral gravity. So you inflate the balloon, and then you turn it down, and the air falls out. Okay, and this is physics, so this is reproducible. Okay, and as I said, it's chiral gravity, so I was doing this with my right hand. So if I now do it with my left hand, I have to do it the other way around. And then it turns out the air falls up.
Now there's just a hole in the bottom. Right?
Who are you?
I don't know.
The spoiler alert. Okay, so here for the nerd. So there's a hole in the back of the bottle. So I gypped you. And actually, if you close the hole, the thing that should trigger you, if I close the hole, it's completely impossible to inflate the balloon because you're roughly halving the volume, which means you're doubling the pressure, and which is double air pressure, so that's like 10 meters of water that you'd be having to blow, and you just can't do that. Okay, now because John was so smart.
It's not the word I use. Hard to ask.
So here's just two pieces of wood, and I want you to get this one out of this one without lifting it off the table. Okay, so clearly you can do that, but that's cheating. And so you can try to do it with your fingers, but I assure you, unless you have super duper fingernails, you won't be able to
Yeah,
do it.
Robin could do it.
No, this is you are the smart ass.
Okay.
Okay, he'll tell us.
Cracking it? I'm not a particle physicist.
Turn the table upside down.
She's already done
John,
that.
we're gonna rotate. No.
How's that?
Just try, yeah, like that.
That's a good idea.
Does one of the students have an idea? Or? So it's just
Oh,
a
I
call
thought-
through and one of the students knew how to do it.
I'll give it a shot.
Yeah, that's what I wanted to do. That's not it.
Blow on
You have to
it.
be
Oh, it's a
good
bit low.
curve, at least.
I want one.
Okay, so I'll just show you how to.
Yeah.
Oh.
It was a whole time.
I didn't want to show up.
Okay, we did an astro section, and if you take a wine glass and you chop it off at the stem and just use the bottom part, it actually has a roughly 1/r potential for light. It's the equivalent, and you get Einstein rings. And you can actually, if you distort them, you can get ellipses and crazy figures, but that's kind of nice. This is the obvious thing to show an expanding universe. This is how we usually conclude the show. So we have the galaxies fixed in paper because they don't expand, and wavelengths, and then